Organic systems designed to reduce tillage begin with cover crops. Cover crops precede the cash crop and are typically terminated with tillage in organic systems. This video is part of a series of virtual field days that will follow research in reduced tillage organic agriculture at WSU Puyallup and Mount Vernon in 2011. The roller crimper is a relatively new tool for physically terminating cover crops. The heavy weight of the implement crimps the stems of cover crops as it rolls over them, crushing their vascular system, but leaves the stalks mostly intact. The plant debris then forms a thick layer of mulch that can help suppress weeds. This model from I&J Manufacturing is 6 feet 6 inches wide. The stage of the cover crop is a major determinant of the effectiveness of this type of physical termination. Toward the end of their development, annual grain crops proceed through heading, pollination, or anthesis, and several stages of kernel development. Most people have had luck rolling cover crops toward the end of anthesis or at the early stages of kernel development, watery ripe, or milk. This is because the plant has allocated the majority of its resources into the seed head, rendering it susceptible to senescence after the roller crimper crushes its vascular system. If cover crops are rolled too early, they are likely to stand back up. On the other hand, if rolled too late, then viable seed might form and cause a volunteer weed problem in the future. In 2010, we initiated a cover crop trial at both the WSU Puyallup Research and Extension Center and the Northwest Washington Research and Extension Center at Mount Vernon. 4 cover crops were planted in fall 2010, with 3 replications at each site. We chose 2 barley varieties and 2 vetch varieties. The barley varieties were Strider and an experimental variety from Oregon State University, OR09913. The vetch varieties were Lana, a type of hairy vetch, and Chickling vetch. Strider performed better than OR09913. There was little difference in the time to maturity, and the biomass was much greater in Strider. Strider produced around 4.5 tons per acre dry matter at Puyallup and 3.7 tons per acre at Mount Vernon, with seeding rates of 76 and 120 pounds per acre at Puyallup and Mount Vernon respectively. The Chickling vetch did not establish well nor survive the winter. Lana grew very successfully and produced around 2.5 tons per acre dry matter at Puyallup and 3.1 tons per acre at Mount Vernon, with seeding rates of 70 and 100 at Puyallup and Mount Vernon respectively. We altered the experiment to plant triticale in the plots that had the failed Chickling vetch. We are evaluating spring-planted triticale for its potential as a rolled cover crop for a fall-planted broccoli. We use 2 methods to terminate the Strider barley: rolling crimping and flailing. Timing for rolling crimping a cover crop is critical. If termination is too early, the crop is liable to stand back up, and if termination is too late, then seed development will be complete and a volunteer weed problem can be created. For effective termination, the cover crop should be near the end of its annual life cycle, but not producing viable seed. In previous trials, we found that cereal rye did not terminate well during anthesis, and that Strider did terminate well at early milk. This year, we terminated Strider slightly later in the dough stage. You can see how the roller crimper effectively crimps the cereal stalk at about 8-inch intervals along the length of the stem. The rolled barley turned from green to brown after about a week, but it also stood up slightly. We will be monitoring seed survival to see if the late rolling created a volunteer weed problem. Flailing is another effective method for terminating the cover crop. Flailing will provide more flexibility in the timing for termination. In our preliminary research, we have seen better yields with flailing and similar weed pressure when compared to rolling crimping.